Right, so I've had a few questions from the group regarding the sediments exercise, and I'm just going to answer two of them in this video. So the first one is to do with the river sample. So I'm just going to download the class data. There it is. So if we go to the end here, you'll see the river sample on this tab. And I've written a note down here that the river sample is just to use the for the last question in the sediments exercise, where we're comparing the river sample to a sample found in the estuary. So you do not need to perform the same analysis, i.e. calculate the graphic mean, standard deviation or skewness for this sample, and that's because the sample is not, well, it's too poorly sorted to be able to perform this kind of analysis to any accuracy. So what we've managed to do is separate it by percentage mass of gravel, sand and anything below a sand 63 microns, so clays and silts. Okay, so that's that question. And then I was also asked by a few people, are my data sensible? And so what I'd like you to do is have a look at the lecture from the computer practical. I'll just download that now. Open that up. And so you can see that on the first slide we've got the Wentworth scale here. So when you get your values of D50, you can have a look at the Wentworth scale. So not just your values of D50 but also your mean size, the graphic mean, and have a look at the fire diameter and see whereabouts your 5 diameters are falling within the Wentworth scale. Okay, and then you can compare where the type of sediment that you've classified it as with what you've seen in your notes. Okay, so the notes that you made when you went out into the field, and that's a good way of being able to decide whether your values are correct or not. Okay, and then when you've worked out your sorting and your skewness, so the sorting is essentially the same as the standard deviation. So once you've worked out the sorting, you can go to slide 7 of the computer practical PowerPoint, and you can see whereabouts your sorting classification falls within this table. So where your sorting value falls within the classification. And if your values are within the sorting classification shown here, then you can be quite confident that they're correct, and you can see whether it's, for example, well sorted or moderately sorted or poorly sorted. As another means of checking whether you think your data is correct, you can go back to your notes again and see whether you did make any notes about how well sorted your sample was. Okay, and then you can go to, once you've worked out your skewness values, you can go to slide 9 and you can have a look at the skewness classification table here. So again, you want to see where your skewness values are falling within this table, and it can help you understand whether your data is finely skewed, near symmetrical, coarsely skewed. And if you're unsure of what that actually means, just go back to the slide before, where you can have a look at what does positively skewed mean. Well, it means an excess of fine particles, and what does negatively skewed means? It means an excess of coarse particles. Okay, so hopefully that will help you think about or make the decision of whether your data is correct or not, or whether understanding the confidence in your data. I'm also going to create another tutorial video very quickly on how to calculate skewness. Okay, so I'll create that hopefully within the next hour or so. Any questions, do feel free to email me. Thanks.